This is Harsha Sharma. I'm a solutions architect at AWS. I welcome you all to this session where we'll be talking about how Goldman Sachs administers temporary elevated AWS access. Joining me today presenting this session are two key members of the Goldman Sachs engineering team, Hannah and Jewel, who are software engineers at Goldman Sachs. We are seeing customers build sophisticated automation to perform actions on their AWS environments, but there are certain use cases that may result in an unavoidable human access of the environment itself. Customers often ask us two questions. What are the patterns to ensure that human access granted is done so in a secure manner with least privileges? And how do you audit this privileged access to see what type of activities were performed by this human user? This session showcases one such pattern that you can consider. On the agenda today, we'll briefly discuss who Goldman Sachs is and the team Hannah and Jewel represent. We'll then look at Goldman Sachs' enterprise environment, where we'll see how their AWS organization is set up, what are the different predefined roles that exist in each account, and how each developer gets read or write access to an AWS account using their custom identity provider. Then, we'll go into the core of this talk, which is to discuss elevated or break glass access. We will see what are the 4 break glass fundamentals that Goldman Sachs used to build their workflows. We'll walk through one such workflow through an end-to-end user story. Before we conclude this talk, we will look at a critical aspect of these workflows, which is that of auditing and reporting. This is extremely important for the industry that Goldman Sachs belongs to. We will see how Goldman Sachs has implemented post-access review to be able to satisfy their security requirements at scale. I will now pass it on to Hannah and Jewel to take you all through the rest of this talk.
Awesome. Thanks, Harsha, for that introduction. Goldman Sachs is a leading global investment bank. Even though we're a financial institution, engineering and innovation are at the heart of our culture. In fact, over a quarter of Goldman Sachs employees are engineers. Jewel and I are on the public cloud engineering team, where we focus on governance and security. At Goldman Sachs, we manage private and confidential data and transactions. So we need to critically think about the best ways to secure our AWS environment. So let's take a look at what that environment looks like. Now, last year, we did a deep dive into our environment setup at re:Invent, titled Architect Governance at Enterprise Scale with Goldman Sachs. So feel free to check out that talk as well. So within the firm, we have a Goldman Sachs organization that houses our application accounts. We have over 500 accounts within this organization, ranging from global investment research, transaction banking, consumer lending, and other business units. Now, we also have a completely isolated and separate organization for our sandbox accounts. But the processes that we're going to be talking about today are really focused on our production and application accounts. And so because we have hundreds of accounts in this organization, we need a way to manage and scale our environment. And so we do a few things. The first is that we have centralized management accounts, such as the primary account, billing, identity, logging, and all these accounts help us manage the environment. Another thing that we do is we have a bootstrapping process that runs on every account when it's created. Part of that bootstrapping process deploys a number of roles, including a read-only role, an operator role, which is limited read-write access, and a break glass role, which is what we're going to talk about today. So having these predefined roles already deployed onto our accounts enables us to utilize federated AWS access to get into our accounts. So let's take an example of how we actually access our AWS account. So here's an example of Alice. She's a developer on the payroll engineering team, and she wants to access her AWS account. So in order to do that, Alice is going to make a request to an internal portal, and that's going to route her request to a custom identity provider. This identity provider is first going to check if Alice is authorized to access this payroll account. If she's authorized, then the custom identity provider is going to make a request to AWS STS on Alice's behalf and assume into the operator role, which is the role that she requested access to. This is going to generate temporary AWS credentials that will automatically expire within 60 minutes. We never want to return long-lived credentials to our users. So these temporary credentials are going to be returned back to the identity provider, back to Alice, and Alice is going to be able to use these credentials to access her AWS account. And so this is the process that we use to enable developers to build autonomously within the firm. But let's say we need to access credentials with elevated access. So what we have is a break glass rule that, as we mentioned, is also pre-deployed to every account. And this has elevated permissions for that role. And so why do we have this role? What's the use case for it? Well, at Goldman Sachs, we automate our deployment of resources using infrastructure as code. So this role is not for the deployment of resources. However, as we know, sometimes our infrastructure as code pipelines break. And if that happens, then the resources that are deployed in our AWS account and our pipeline might be out of sync. And so in that case, someone will need to manually go into the account and remediate the resources that were corrupted. Another example of when we might need break glass role is, let's say Alice, our developer, is deploying an S3 bucket, and she wants to secure her bucket with an S3 bucket policy. Now she ends up creating a bucket policy that's too restrictive and has locked herself out of her own bucket. Well, in that case, someone needs to go in and edit the bucket policy so that Alice can regain access. So it's times like these where we need to be able to access credentials with elevated permissions. But because these credentials have a lot more permissions than the operator role and definitely the read-only role, we need to critically think about how we're going to broker these credentials. And so there were 4 key fundamentals that guided our solution for how we were going to give out these credentials: governance, the principle of least privilege, time-bound approval, and review and audit. So let's take a look at each of these. The first is governance. And this is the idea that although we want developers to be able to build autonomously, when it comes to the break glass role, we pull in the reins and set up guardrails. And so one of those guardrails is that only a select number of people within the firm can access break glass into any account. We have a select number of admins within the firm that can break glass into our AWS accounts, but not every developer can access the break glass role. And so that's our first guardrail. We're limiting the number of people that can access this break glass role to only admins. Next is the principle of least privilege. And that's, even though we need elevated access into our AWS account, we don't need unlimited access. And so if you'll see here on the right, there's an example of an assume role where we're passing in the pre-deployed break glass role into the account that we're trying to access. We're setting the duration to 60 minutes, so the credentials generated here are automatically going to expire after 60 minutes. But what we can also do is pass in a policy. And what this is doing is it's altering the permissions of the break glass credentials at runtime. So what's happening here is we have that pre-deployed break glass role already in the account, and that already has a policy associated to it. But when we pass in the policy here, the effective permissions of the credentials are going to be the intersection between the policy that's deployed and the policy that we're passing in. So if we go back to the example where Alice created an S3 bucket policy that was too restrictive, well, in that case, the admin that's going to go in and edit the bucket policy only needs access to S3 resources within the account. They don't need any access to secrets within Secrets Manager or EC2 instances within the account. And so by sending in this S3 policy profile, we're ensuring that the credentials generated are scoped down to only have permissions for the resources that are needed to be actioned on for that session. Now, not only are we limiting the number of people that can access the break glass role, and we're limiting the scope of the credentials generated, but we want to make sure that no one individual can access these credentials on their own. And so what we've built is an internal time-bound approval workflow, where before an admin can gain access to the break glass credentials, they have to have a valid reason to access those credentials, raise a request, and that request and reason have to be reviewed by a second admin. Only after that second admin has approved the request does the first admin gain access to the break glass credentials. And so by having this approval workflow, we're always ensuring that there's a valid reason for accessing these break glass credentials, and that two people are always involved in ensuring that that's happening. And so with that, I'm going to pass it off to Jewel, who's going to take us through what it looks like to break glass at Goldman Sachs.
Thanks, Hannah. So now we're going to continue with the example that you mentioned earlier of having to go into the console to fix an S3 bucket policy that is too restrictive. So here we have a demo UI representing our production payroll AWS account. Now, as we mentioned earlier, we have predefined roles that are bootstrapped into all of our accounts. So with the console buttons on screen, accessing them will allow developers to assume into one of those predefined roles to access the AWS management console. But for the break glass console, only admins can access this. And then for the read-only and the operator console, developers on the payroll engineering team use those to develop in the AWS account. So we have Alice, who is a developer on the payroll engineering team, and she was requested that Mary, an admin on the cloud team, go in on her behalf so she can fix the S3 bucket policy she placed on her bucket that was too restrictive. So here at Goldman Sachs, we track our break glass sessions utilizing a leasing system. So if Mary were to try to get into this account without a lease, she's going to see a 401 unauthorized error stating she has no active lease. So in order to get one, she must first request it. And just like the break glass console button, only admins can request a lease. So here we have the different fields that an admin needs to fill out in order to get a lease request. So first, we have the reason. Now, here at Goldman Sachs, we also have as a requirement that in order to have an admin go in and break glass on a developer's behalf, they must first fill out a support ticket. So Alice has filled this out explaining what happened and why break glass is needed in order to unblock her. So Mary has included this ticket in the reason and also has provided a short description so that the second party who's going to review this request has some context into the ticket and can see that it's an acceptable use case. Next, we have the policy profile. So we have predefined policies that include common resources needed in conjunction for support tickets. So the S3 profile is going to include resources like KMS, S3, and IAM. So Mary has selected this profile since she only needs to go in and get this access to fix an S3 bucket policy. And then lastly, we have the duration. So this is how long our internal identity provider has to make the assume role request on Mary's behalf. Now this duration is going to be the duration of the lease, which is separate from our credentialing durations. We have credentials that always will expire after 1 hour. So because Mary has requested for her lease to be 2 hours, if she's not done working alongside Alice within the first hour of receiving her credentials, our internal identity provider can go back in, see that her lease is still active, so she can request new temporary credentials to continue developing alongside Alice. So now, once Mary submits this request, it's going to email the admin team. So here we have the inbox of Daniel, another admin on the team, and he has received all the details of her request. So now he can go in and review the details, ensure that this is an acceptable use case, and he can go in and approve it on Mary's behalf. So he has approved this request, and now our internal identity provider is going to email Mary back, letting her know that her request has been approved and her lease is now activated. So all of these details are easily viewable inside of our inbox, but we are also keeping track of it in our lease inventory. And so for our lease inventory, we're utilizing Amazon DynamoDB. So inside of our DynamoDB table, we are keeping track of all the fields related to the lease request. So these fields are something like the lease ID, which is going to be a unique ID associated with each lease request, and even more fields such as the approval time, the user that requested it, the policy profile, the duration, and even more such as who approved and the status of the lease. So when Mary requested this access, it's going to add in a new entry to the table utilizing AWS Lambda. So that new request that comes into the new entry that comes into the table is going to have a status of pending. So once it is approved by our second party, it's going to update the status of that lease to be approved, therefore activating the lease. So now that Mary's request has been approved, let's continue on with our user story. So it's been approved, so now when she goes back to our demo UI and clicks on the break glass console, she's actually going to get access into the account because our internal identity provider has seen that she has an active lease. So now that we've walked through how an admin break classes here at Goldman Sachs, we can go in and look at our full architecture for this break glass pre-approval workflow. So here we have Mary, who needs access into the payroll account. In order to get that access, she's going to hit our internal identity provider, which is going to make the same check as it does for all developers within Goldman Sachs. It's going to check in our corporate directory, does she have access to this account? Is she authorized for it? And because she's an admin, she is. But because she's going in for break glass access, it's going to have that added step of inputting an entry into our DynamoDB lease inventory. Now, this DynamoDB table is stored in our management identity account. So, utilizing Amazon API Gateway, AWS Lambda, and DynamoDB, our internal identity provider can input that entry into the table. Next, our identity provider is going to email the team of admins to let them know that Mary has requested this access. Our second party is going to review the request and approve it, and once it's approved, it's going to update her entry in the DynamoDB table, activating her lease. So now, when Mary goes to hit our break glass console button, which is going to trigger our internal identity provider, it's going to check in the table, does she have an active lease? It's going to see that it is activated, and therefore it can continue on to make the AWS STS call to assume role into the account and assume into the break glass role. So now, Mary will be administered a temporary AWS credential, and she can actually access the management console. So this is our full pre-approval workflow that we use to get break glass access here at Goldman Sachs. Now that we've seen this, it brings us to our final break glass fundamental, which is going to be review and audit. So here at Goldman Sachs, we have over 500 application accounts. And with that, we had to build out a centralized system to be able to review these break glass sessions after they have been completed. So just like how we have a second party who approves the request before getting the access, we're also going to have a second party that reviews the actions that were taken by the admin within the account. Now, we listed this as a fundamental, not only because it's an audit requirement for us here. As a bank, security is of the utmost importance to us, but also we wanted it to be a best practice for us here at the firm whenever giving out these elevated credentials. We want to make sure that with this elevated access, we have a second party that's going to review it so that we ensure that the admin did not misuse this elevated access. And with that, I'm going to pass it back to Hannah to walk us through this post-access review workflow.
So we have all this AWS activity happening within our accounts in the organization. We have developers accessing the read-only and the operator role. We have them deploying infrastructure using infrastructure as code, and we have admins accessing the break glass role. And so all of this activity is generating CloudTrail logs. And so what we have is an organization CloudTrail that persists all of these activities. Now, because for the review and audit, we only care about the break glass activity, what we have is a subscription filter that's going to filter out all the CloudTrail logs related to break glass. And it's going to pipe those logs into Kinesis Firehose, where the data is going to be formatted and partitioned and put into our S3 bucket within the identity account. Now, once it's in our S3 bucket, we can use Athena to query back all the session logs that we need for our review process. Now remember, we keep inventory of all the leases in our DynamoDB table. So we know all the break glass sessions that should have taken place within our organization. And so we can use this data to guide our queries and pull back all the related session logs that we need. And so we take that data and we pipe it into our internal workflow review. And this is where a second admin is going to come in and review the session logs for a specific lease to ensure that the actions taken are appropriate. So this is our workflow process that we use to get the data into a consumable format so that we can use it for review. Let's dive a little deeper into how we actually implemented this. So remember that assume role that we showed earlier. We're passing in the role, the duration, the policy. Well, the one thing that we left out earlier is that the session name is not only going to be the user ID in this case, but it's going to be the user ID and the lease ID. And so all that data that we're storing in the DynamoDB table, such as who approved it, why the request was raised, how long it should be valid for, is we can associate back to these credentials because we have the lease ID being passed in as the session name. Also, as Jewel mentioned, we can raise multiple sessions against one lease. And so as we raise multiple sessions, all that session activity can still be aggregated together because we're passing in the lease ID. And so we know all the actions that were taken against one lease. And so if we look at an example of a CloudTrail log, here's an abbreviated version of what a CloudTrail log might look like. You'll see at the bottom there's event source and event name, which corresponds to the resource and the action taken on that resource. And so these are the actions that Mary took during her maybe multiple sessions. And what you'll also see is that the user identity, ARN, is also tagged with the session name that we passed in. So that lease ID is going to be associated to all the actions taken against multiple sessions. Like we mentioned earlier, we are filtering out all the break glass CloudTrail logs, piping them into Kinesis Firehose, into our S3 bucket. And once they're in our S3 bucket, we can use Athena to write a SQL statement and pull back all the session logs that we need for our review. And again, because we have the lease ID associated to all the CloudTrail logs, we can use that as a filter parameter to pull back all of the CloudTrail logs for this one lease. And so we take those logs and we populate a custom UI where we're going to present all the lease details, including the reason why the lease was created and all the actions that the admin took for that lease. And so another admin is going to come in and ensure that those actions make sense with the reason. And so having this review process is really ensuring that we're utilizing the break glass credentials appropriately for these sessions. But because we're also pulling together all of this data for the break glass role, we're able to also answer macro questions such as, how often are we breaking glass? What are the main reasons we're breaking glass? How long do these sessions usually last? And when we can start to answer those questions, we can start thinking about ways to automate these processes and improve our environment even further. Also, we can identify trends that might point to abuse of the break glass role. And being able to identify these trends and answer these macro questions enables us to iterate over our environment and secure and improve it. And so with that, I just want to summarize a little bit of what we talked about today. We went through the fundamentals that guided our solution to brokering break glass credentials within the firm. We're limiting the number of people that can access the break glass role to only admins. And rather than having some star role that's deployed in all of the accounts that maybe even only the admins can access, we're limiting when they can access this break glass role, and we're scoping down the credentials to ensure that they only have access to the resources that are relevant for those sessions. On the flip side, we're reviewing everything that we're doing with our break glass roles to ensure that they're being used appropriately. And so these processes that we've implemented enable us to ensure that we're brokering the credentials in a secure fashion. Thank you so much for listening today. We really hope you enjoyed our talk.